Okay, is my screen visible?
Yes, sir.
Okay. So in my last session, I showed you how to build a doubly linked list. So doubly linked list contains nodes with two pointers, one pointing to the next node, another pointing to the previous node. We saw how to add and how to append, but we were yet to explore how to insert a node in between. So if you look at this linked list scenario where I want to insert a new node with value 9 after 3. So again you have to traverse the linked list from the beginning. You have to make t point to head and t data not equal to x you have to traverse. So once you locate x, which is 3 in this case, you have to stop, and the new node has to be created with the value y, which has come through the method insert node. Now this new node, if it has to become part of this linked list and get inserted after 3, what all changes we have to do? So the first change that you would do is to make the new node next point to the next node of t, isn't it? So how do you do this? New node arrow next equal to t arrow next, isn't it? So this is the first thing that you would do, right? Now the previous pointer of node 5, this one, this is pointing to 3, but this should point to the new node, isn't it? Because the preceding node of 5 will now become 9. So how do I make this node point to this node? Okay, so we know that t arrow next will point to node with value 5, and we can use another arrow and use previous. Can I do this? Hello? T arrow next points to this node, and to access this node's previous you just have to use one more arrow and use the previous pointer. This should point to new node. So what effectively happens in the diagram is this link is removed and this node previous will point to this node, correct?
So can you explain again, sir? I didn't follow.
Okay, so the first step is a new node should be after node 3. So the new node next should point to, this is next, right? New node next should become equal to t arrow next. T is here. T arrow next is this one. That is what is done by this part. Okay. But after insertion, this node 9 will be the preceding node of node 5. So to make node 9 preceding node of node 5, I make t arrow next arrow previous. It means there is a pointer here which is previous. The next of this is anyway null, that you leave it. Now the previous of this which was pointing here now should point to this node, correct? So when I do t arrow next arrow previous equal to new node, this previous pointer which is here will point to this node. Okay, and now if I make t arrow next equal to new node, right? Now this has to point here. Okay, before t arrow next is made to point here. Now the previous pointer of new node, this should point to node 3, right? So new node arrow previous equal to t. So this will point here. Okay, so 4 pointers have to be altered if you want to do one insert in a doubly linked list. Okay, in singly linked list this was pretty easy, you just have to alter 2 pointers, but here you just see 4 pointers have to be altered. Is this procedure clear? Or you still have some doubts? See, one thing to understand is that every node has a pointer previous and a pointer next. Okay, so both these pointers have to be altered. The next pointer of 9 should point to this node, and the previous of this node should point to this new node which you are inserting, because this 9 will be in between 3 and 5. Now after you have altered this next to new node, this you can remove, correct? And the previous
So
of,
then why is this line like you are connecting to the previous of 3?
because it's a doubly linked
Um,
list. It's a doubly linked list. See the node 7 and 3, what has happened? In node 7 and 3, the next of 7 is pointing here and previous of this is pointing here. Same should happen with 3 and 9, no? Next of 3 should point to this node and previous should point to this node. Confusing? Yeah. Because see here this pointer you can point here or here, doesn't matter, you
you
can
see,
put it here.
between 7 and 3 you have given this is previous, right? After 7 is previous to previous, previous to then to previous.
See, this is next of 7 which is pointing here.
Okay.
This is previous of 3 which is pointing here.
Okay.
Okay, so don't think this previous is pointing to this next pointer here, it is pointing to this node.
No.
Okay, so don't think it is pointing to the pointer, it is pointing to the whole node. It can access next, it can access data, it can access previous also. Previous of this is null anyway. Okay, to make a new node part of the existing linked list, insertion in between the linked list involves these 4 steps. Okay, so you have to traverse the list until you find the element 3, which is x, and then after 3 you are inserting a new value y, which is 9. So this is 3 and this is 9. It means after you called insert node with value 3 and 9, the new linked list will contain 9 as part of the new linked list, and if you traverse the list from beginning to end, 7, 3, 9, 5 should be printed. Okay, so this is the insertion part. Is that clear? So we will see that in the demonstration. Yeah, now delete node is what we need to look at. You want to delete a given value x in the linked list, x equal to 3. Suppose you want to delete 3. Okay, so how do I do that? So
Actually, you have to traverse to find that the particular variable,
Yeah.
the number is 3,
yeah,
and then you have to get the meaning you have to remove the previous next.
yeah. So we need 2 pointers here, one previous, one current. So t will stop at 3 and previous will be following. If t stops at 5, then previous will be at 3. Likewise, right? So previous pointer will always precede t. So once you get this scenario, we have to alter certain pointers. So what all pointers we have to alter to get this out of the way? Now first thing is the next of 7 should point to 5, isn't it?
5.
So previous arrow next equal to t. T arrow next. If I do this, tell me what all will happen.
Yeah.
This is removed. And effectively when I do previous arrow next equal to T arrow next, this will point to this node. Right? And now the 3 anyway will go. The previous pointer of 5 should now point to node 7. So T arrow next. Now the problem is you should have done this first. Otherwise what happened? T arrow next is lost no here.
No, still the T will be pointing to
Okay.
that 5
T is
3
pointing
only,
here.
right?
Okay, you can do that. T arrow next arrow previous will be equal to previous, just previous.
Yes.
So that this pointer
No, we have not removed that 3's next still.
will point here. Correct. Right. Now if you delete T, this whole node is gone. Correct. So there are 3 steps here. Previous arrow next equal to T arrow next will make this node point to the next node following value 3, and T arrow next arrow previous equal to previous will make this point here, and you can free that node. So this gets deleted. Fine?
Sir, actually, my doubt is like you've given previous of next is equal to T arrow next, right, sir? How does it take that exact previous? I mean, it will be first, it will traverse till where the T is there, place the position, and then it takes the previous of next.
Yeah. See, we are traversing the list from the beginning. Initially, T will be head.
Okay.
So while T not equal to X, or T arrow data not equal to X, you have to make T equal to T arrow next. And before you do this, you make previous equal to T.
Sir, instead of that, can't we do like T of previous is equal to previous, like that? Can we just say like node is equal to we will just say like node is equal to node previous equal to null pointer. Then once we reach the T is equal to, if T of data is equal to X, then we make that T of previous is equal to previous, T of previous is equal to previous, and that T of next will be next only, right? So we make not traverse previous as and when we do the T.
No, there could be another way of doing the same thing, but if you follow these 3 steps, you will get effectively that node T removed.
Right.
Okay, there could be another way of doing it with another set of pointers or like that.
Okay.
So this is the most efficient way of doing it because we want to alter only 2 pointers here. Only within 2 steps you have altered the pointers, and the third step is just delete that node, so that memory allocated for that node is taken away. Okay.
Right.
So let's see these 3 steps implemented in our code. So if you recall, we have done this previously, that is add node, append node. Insert node we have to do first. So here in the insert node, first thing is you create a new node. Into which you store y, and you have to search for value x. So for that again you take node star t equal to head, while t arrow data not equal to x, you say t equal to t arrow next. Okay. So once you come out of this loop, either you might have reached the end of the list or you might have found x, right? So if t not equal to null pointer, it means you have found x in the list. So we need to alter few pointers. So if you see the code we have written here, so new node arrow next equal to t arrow next. So that is the first step you have to do. New node arrow next equal to t arrow next. Okay. Then the next step is t arrow next arrow previous equal to new node. T arrow next arrow previous equal to new node. Okay, there are two more pointers to be altered. T arrow next equal to new node. T arrow next equal to new node. And new node arrow previous equal to t. Okay, so if you only see this code, it's very difficult to understand what I'm doing here. Okay, so this all code need to be understood with the help of a diagram here. So that is why I took this diagram and explained to you what I'm doing here. Right, so after you locate t, you have to alter these 4 pointers to get the insertion done. Let's see whether that insertion has happened correctly or not. Before that, we just say in the else part, you can see out not found. Okay, so I already have a doubly linked list. We have done append and all that. Here I am going to insert. So doubly linked list dot insert node. So I have added 9 3 5. They will be in the reverse order 5 3 9. After 3 I want to add, let us say, 7, so that in the output we will get 5 3 7 9 22. Okay, so let's see, it's showing some error there.
Forty-six.
It should be previous. Yeah. Okay, delete node we have not implemented, it's giving warning that you can ignore. Now just observe here, we had 5 3 9 22, and after 3 I wanted to insert 7. So after insertion we get 5 3 7 9 22. Okay, and if you print that in the reverse order, 22 9 7 3 5 will come. Now deletion part we have to implement and see. We also do that. So this is insertion is working fine. So let's see how we can do the deletion part. So in deletion part we have to take again 2 pointers, node star t comma equal to head, and one more pointer, node star previous. So don't get confused this previous with the previous that we have in the new node. This is just a pointer. It will point to the preceding node of t. So here, while
Sir, for that you may just take it as like node star previous node. node.
Okay, you can call it as previous node. Okay.
Yeah. So now it will not take
Yeah.
place.
Okay. So here now, if you see, when you want to delete this node, you just have to check whether while this is not equal to x, you just have to say t equal to t arrow next. But before that, you have to remember the previous node equal to t. So these two have to happen, and they should be in the block so that both are executed. So when you come out of the loop, again you check whether if t not equal to null pointer, then you have to delete that node. So first thing is t arrow next should be equal to previous node arrow next should be equal to t arrow next, so that the node t is bypassed, correct? And t arrow next arrow previous should point to the previous node, correct? And then now you just say delete t, so that memory allocated for that node is reclaimed. And here you can give else and cout x not found. Right, so let's see whether we'll be able to delete something. So after displaying here dlist dot delete node, now we already have in the list y379. So let me delete 9 from here. And in the list after deletion, we should get only 53722. So let's see whether that happens. Okay, so that 9 is deleted. So would you like to implement and see?
Yes, sir.
Okay, just give.
Yes.
First you do insert mode and then delete mode. I will just I guess yesterday we implemented rest of it. So just note this insert node has two arguments, int x and y, and you are creating a new node which will contain y, and you traverse the list until you find the element, and if it is not null pointer, you have to do these steps. So node types also have to be checked. We have both the values. this should work for us. So even the doubly linked list, we should define that activity here. That error. If you want, you can create doubly linked list. Then so let's say whether this works out. Okay, works. You can try insert and other things. Should work fine. So we discussed doubly linked list and how to generalize and implement all its operations. Now there is one more thing that we need to learn. That is, we have to implement a singly linked list which is circular in nature. So that part I think so we shall take it up next time, because there is a lot of background noise, there is some drilling going on. Okay, so before that I just want to explain to what is circular linked list. Is my screen visible? Okay. See, singly linked list we have seen. One problem in singly linked list is, of course, this should be singly linked list.
And one of the
Let us assume this is singly linked list. And in singly linked list, if you traverse forward, you have to keep going forward, and there is the end node will be like this. So you cannot traverse backward. Now, if I make this linked list circular, that is the last node, if I make it point to the first node here. Okay, so this becomes a circular linked list. Now, the advantage is somewhere, if you are somewhere here, okay, and you want to visit 3 again, right? So let us say this is t. So again you can say t equal to t arrow next, while t arrow data not equal to 3, you can do this. So what happens? You make this t will come back here, and again it is not equal to 7, again it will move here, and when it hits 3 it will stop. So t can traverse back in the circular linked list has this advantage, and we shall see in our next session how to implement a circular linked list. Right? I could have shown today itself, but with a lot of background noise I am not able to spell out everything correctly. Okay, so this part, circular linked list, if you get some documentation on the internet, I will share that with you. Try implement that, and anyway we shall see how to implement this circular linked list in our next session. Alright?
Sure, sir. Thank you.
So,
Sir, I just wanted to know, like, how many topics are left?
okay, now this circular linked list, after circular linked list we have to consider trees, binary trees, because if you look at C++ template class, it uses map, no?
Yeah.
So map is implemented using tree. So the tree part I will cover, And again in tree we have minimum heap and maximum heap. The heap tree we have to consider, and the concept
That
of
upper bound and lower bound.
yeah, and there is a concept of red black tree, which is what is implemented in your map. So the concept only I'll explain, the implementation part will not be there. And we will come back to the template classes we saw in C++ and revisit vector, array, link, this vector, linked list and all that. There you will understand what these things are really.
Okay.
Yeah. And possibly a few algorithms using these trees and all. Yeah. So maybe another 4 or 5 classes you should be able to cover data structure.